Every algebraic expression has at least one coefficient. Now, the coefficient of a term in an algebraic expression simply can be seen as the factor of a particular term in that expression. If you remember what you learned when we discussed factors, understanding algebraic coefficient and how to find it will be really easy for you. Meanwhile, I'm going to throw more light as we solve the problems we have on the board. We are required to identify the coefficients of each of the variables that make up the terms of the expressions below. So by this statement, you can easily identify that as long as you have an expression containing variables, which is always true, there is going to be a coefficient or coefficients. Therefore, let's take a look at these examples. We have 2x plus 5y minus 3. We have two major variables here, which are x and y. For the x, there are two of them, 2x. For the y, there are 5 of them, that's 5y. This is a constant, negative 3. Constants do not have coefficients if they are standing on their own. Therefore, negative 3, we can find a coefficient on that side. But every variable has a coefficient. And the coefficient of every variable is that number or number and other variables next to it. Let us discuss it straight away by solving these problems. So the very first thing you do when you want to identify the coefficients of a particular term is to simply identify all the terms in the expression. So for number 1, the terms in this expression are 2x, positive 5y, and we have negative 3 also as one of the terms. So for the x term, we will need to look for the coefficients of x and y because they are the variables that we have here. For x, the coefficient is 2 because 2 is the number nearest to x. This is 2 times x. So 2 is one of the factors that make up 2x. So we bring it out. 2 is the coefficient of x, and for y, 5 is the coefficient of y because that's the number nearest to y. It's as easy as that. Take a look at number 2. X plus 2y minus 5z. Every term in this expression has a variable, so it means we are going to identify 3 coefficients of each of the variables we have here. Therefore, we are identifying the coefficients of x, y, and z. Now, something important you should know is always remember to identify all the terms. The first term here is just 1x. Therefore, the coefficient of x is 1. The next term we have here is 2y. It's positive. Therefore, the coefficient of y is 2. And the next term we have is negative 5z. Therefore, the coefficient of z is negative 5. Take note of the sign, negative 5, not just 5. Number 3, it's easy. We have 2c squared plus 3b cubed minus a squared fifth. In this case, we also have 3 terms making up this expression. I'm going to identify the terms. We have the 2c squared, we have the 3b cubed, and we have the negative a squared upon 5. So we are identifying all the coefficients of each of these terms that make up this expression. So let's write them out quickly. We want to identify the coefficients of, what are they? The first one is c squared. And the c squared has 2 as its coefficient. The next variable we have here is b cubed. B cubed, and the coefficient of b cubed is positive 3. And the next variable we have, or the next term we have, is a squared upon 5. For a squared, the variable that is next to it, which is the coefficient, is negative 1 upon 5. How did we know that negative 1 upon 5 is the correct coefficient? We know so because negative 1 upon 5 multiply a squared will leave us with negative a squared upon 5. That's how we know. This is 1a squared. So with a negative sign next to it, that is negative 1a squared upon 5. So that 1 and 5, take note of them, very important. Next is question 4 with also many variables appearing here, not just 3 of them. We have 3 terms, but the variables are more than 3. Therefore, let's identify them. In the first case, where we have the term 2/5 of x, we are going to identify the coefficient of the variable x. In this case, the coefficient of the variable x is 2/5. Next term we have is negative xy upon 3. Here we can identify coefficient for x differently, coefficient for y separately also. So let's do it. So if we do that from this angle, the coefficient of x is going to be negative y upon 3. Take note of that. Did you see that a variable can also appear as coefficients? Remember I told you in the beginning of this class that a coefficient, you can see it as factors that make up a particular term. So the factors that make up negative xy upon 3 are negative x times y upon 3. Therefore, since we have separated x and we're looking for its coefficient, the coefficient is suitably negative y upon 3. Then what is the coefficient of y? The reverse is the case. The coefficient of y for this expression here, y, the coefficient is going to be negative x upon 3. Negative x upon 3. Did you see that? Now let's go to the last case, which is yz. They are all positive, so this is easy. The coefficient for y in this term will be z, and the coefficient of z will be y on the other hand, because they are the only two things we have. Y times z is yz. Therefore, each of the variables serve as a coefficient to the other. Final question is 3yb minus 6t minus 2ty plus 7 upon 2 xv. xv standing in numerator place. We are going to critically, looking at question 5, 3yb minus 6t all over 2 minus 2ty plus 7 upon 2 xv. There are so many variables we need to look at. We have y, we have b, we have t, we also have t again in this term, and we have x and v on this side. So there are many of them. For us to be able to find out these variables that we have here, what their coefficients stand for, it is good to break it down a little bit to make our work easy. These which you have here, this term can be broken down or simplified into 3 upon 2 of yb separately minus 60 upon 2 separately. Did you see that? Minus 2ty plus 7 upon 2 xv. So with this it becomes easier. 6 upon 2 can be simplified further to 3, so we can just write this as 3t. Now let's find it out. Looking at the first term, which has 3 upon 2 yb, the coefficient of y, which we have here, is 3 upon 2 b. The coefficient of b will be 3 upon 2 of y. This is done, solved. Now for the next term, which is negative 3t, we just need to look for the coefficient of t. And the coefficient of t here is negative 3. This is also solved. Now let's take a look at the next term. The next term we have here is negative 2ty. So there is t and there is y. We need to look for their coefficients. For t, the coefficient is negative 2y. And for y, the coefficient is negative 2t. This is also done. It's as easy as that. And finally, the last term we need to solve is term 7 upon 2 xv. In this case, the coefficient of x is the same as 7 upon 2v, while the coefficient of v is the same as 7 upon 2x. This is how to find the coefficient of any algebraic term. Now that we're done with this stage, let's see some problems that we can tackle.